Today we are going to solve four problems from Griffith, uh, which are very simple but very interesting. Uh, that is, we are going to solve problem from 6.2 to 6.5. Now you take the problem 6.2. So that for Hermitian operator Q cat, the operator U cat, which is equal to e power plus I, the operator Q is unitary. We have to prove that this is unitary. So the operator U is equal to e power I Q. Here Q is the operator. We can expand this using the power series. That is summation over 0 to infinite I q cat to power n over n factorial. Similarly, e power minus iq is equal to summation over 0 to infinite minus iq power n over n factorial. Here, u dagger is equal to just inverse of it. If you take complex conjugate of this I will become minus I. That is, which is nothing but u inverse. So u dagger u inverse is equal to unitary matrix. That is, e power iq multiplied by e power minus iq is 1. Here 1 we are writing in the unitary operator. So we have solved the problem 6.2. Now we will move on to 6.3. Now the problem 6.3 is so that the operator P prime obtained by applying the translational operator uh, P is P prime, which is equal to T dagger P T, which is equal to P. We have to prove this. To show the momentum operator is invariant under translator. So this is the symmetrical one. So P prime by definition we have seen that T dagger P T dagger. So let P dagger act on some arbitrary function f of x. So both left hand side as well as in the right hand side. This translational operator is e power minus a p. P is the operator over h cross. When it act on this, it produces, that is, when this exponential operator act on f of x, you will get f of x plus a. There is a translation in the position. So this will become d dagger p cat f of x plus a. Now this p you can write replace the p by its operator, that is minus I h cross d by dx. So what you will get if you differentiate this function f, you will get f prime. F prime is shows the derivative. So here you have d dagger. So this d dagger is a complex conjugate of this d. So it produces shift towards the positive direction plus a. Then d dagger, t is e power minus ap over h cross. So t dagger is equal to e power uh, e power uh, plus I will minus I will become plus a p p cat over h cross. So this will shift in the opposite direction. That is, x will become x minus a. So minus a plus a will get cancelled. You will get I h cross f prime x. So here we have replaced because there is a shift when you are doing translational operator. There is a shift. This x will become x minus a. So here plus a. So this will become I h cross f prime of x. So what is f prime is nothing but t by tx of f of x. So already there is minus I h cross. What is this minus I h cross t by tx is nothing but the momentum operator. So P prime f of x is equal to P prime f of x. So, sorry, P prime f of x is equal to P f of x. So, the momentum operator is invariant under translation. So, we have proved this. Now, we will move on to problem 6.4. Now the problem 6.4 is prove the equation 6.8. You may assume Q, which is a function of x cat p cat, that is position operator and momentum operator, can be written in a power series. The operator Q, which is a function of operator x and p, canonically conjugated one, which is equal to summation over m0 to infinite summation over n is equal to 0 to infinite am uh, x cat m p cat n for some constant am. Now we have to prove this equation, that is q prime x x cat p cat is equal to d dagger q x, because it's a unitary operator which will not change the norms. So q cat, which is a function of x cat and p cat, which can be written as q cat x prime cat p prime cat. But we know just as in from problem 6.3, p prime is equal to p. So x prime we have seen already is x plus a. So we have to prove this. So now let us the unitary operator act on the operator q. That is t dagger q t dagger is a function of x and p, which is defined by this expression. So you take dagger translational operator, that is t dagger, and this thing inside the bracket, that is q x x cat p cat. I am writing this, and t dagger. Now we can rewrite this. You take am as a constant. So this can be written as t x cat t dagger power m, and t dagger power n. So we can separate into two portions. Now we will see what will happen. Now we got this expression. So here you can see this will become when unitary operator, that is translational operator, act on operator x, then this x will become x plus a, and this is x plus a, that is operator x plus a. This is p prime. In fact, p prime is equal to p. So we can write this as q cat x cat plus a, which is the function of x cat plus a p prime. And we know this can be rewritten as x plus a can be rewritten as x prime, and this is p prime. But by definition, this x prime can be written as x plus a, and p prime can be written as p. Hence, we have proved the problem. Then we will move on to problems 6.5. Now we are going to solve the problem 6.5. The problem 6.5 is so that the equation 6.12 follows from equation 6.11. Equation 6.11 is psi of x minus a is equal to e power minus iqa psi of x. And the equation 6.12 is psi of x is equal to e power iq x u of x. Here Q is the crystal momentum. So the second one, 6.12 is our Bloch's theorem. Now you take equation 6.12. You take the equation 6.12 and let translational operator act on both sides. That is left side as well as right side. Here in the right side, when translational operator is here, it is e power minus iqa. Here also e power minus iqa. When e power minus iqa act on this, you will get psi of x minus a. Similarly, here you will get e power u x minus a, but this and this, if you combine, you will get e power I q x minus a. So I have written this as x minus a. Now you can expand this, separate this. E power iq x first term and minus iq a u of x minus a. Now you can see from the equation 6.1, this can be written as, you can see from equation 1.1, 6.11, sorry, equation 6.11. From equation 6.11, uh, psi of x minus a is equal to e power uh, minus iqa. So iqa psi of x, yeah, this one, 6.11. So I am utilizing the equation 6.11. Then you can cancel out this exponential term, exponential minus iqa, here exponential minus iqa. Then this equation will become psi of x equal to e power, here you have iqx u of x minus a. Now we will further simplify this. So just now we got this expression, that is psi of x is equal to e power iqx u of x minus a. But from equation 6.12, that is psi of x is equal to e power iqx ux. So I am replacing this by this from equation 6.12. So here now what we can do is we can cancel both the exponential term. So you will get u of x is equal to u of x minus a. This is the crystal periodicity. So thank you very much for watching my video and supporting me continuously. Thank you very much.